Okay, so when we talk about the cochlea, it is going to be like this. Okay, just imagine it to be 3D. So it is going to be like this, and it has got three parts. Okay, what are going to be the three parts? We have the cochlear duct, and around it we're going to have the vestibuli, and then in front of it we're going to have the tympani. Okay, that when it is like this, okay, and you see it like this, it is going to be raised, right? And then you cut a slice like this, and then you see it like this, it will be having three openings, right? And that three openings is what is going to be seen over here. So we have the scalar vestibuli over here, and then we have the scalar cochlear duct over here, and we have the scalar tympani over here. Okay, we have the scalar tympani over here, scalar vestibule over here, and the cochlear duct over here. So this part is what we need to focus on, because both the scalar vestibule as well as scalar vestibule and tympani, both of it is going to have the same lymph, which is going to be the both of it is going to have the same endolymph. Okay, and both of us, when it comes to the top, so how is the flow going to be? We're going to have the endolymph like this. Okay, and then it is going to come all the way here, and then from here it is going to move back into the helicotrema, and then it is going to fill the this one as well, that is the scalar tympani as well. So this is the part that we need to focus on. So when we talk about this cochlear duct, okay, it is going to be bounded anteriorly by the vestibular membrane, okay, by the vestibular membrane, and base is going to be done by the basilar membrane, okay, the basilar membrane. And on top of the basilar membrane lies this coiled organ, which is called as the organ of Corti, and that is going to be having these hair cells, which is going to send in the information via the cochlear part of the spiral ganglion, cochlear part of the vestibular cochlear nerve. So what happens is that it is gonna the hair cells are going to be inserted into this membrane, which is called as the tectorial membrane, and with every jerk from the ossicles, there is going to be movement, corresponding movement. Like for example, see, there is going to be a jerk in the ossicles, there is going to be the movement seen in the oval window. From the oval window, the movement is going to pass through the hydrostatic pressure, it's going to move through the the scalar vestibuli. It's going to go to the helicotrema, come back along the scalar tympani to the oval window, okay, and to the round window, and that is how the damping occurs. And while this is happening, both of it, there's going to be pressure, and because of that, there's going to be a pressure against the basilar membrane, and because there's going to be pressure against the basilar membrane, this organ of Corti is going to move against the tectorial membrane, and that is going to lead to the hair cells getting depolarized, and that is going to lead to the nerve impulse getting generated, and that is how sound is heard. And this is about inner ear. I hope I made sense.